Hello, welcome to my channel. In this video, I'll be discussing motion. It will be an introductory part of motion. Motion is changing position of a body relative to time. Simply put, motion is movement. When a body moves from one place to another, that is motion. As simple as that. There are different types of motion. One of them is rotational motion. And rotational motion is otherwise known as spinning motion, where a body spin along its axis, okay, in a circular version, like that of the moving hand of a clock is in rotational motion. Okay. Another example I can give is a car. When the tire of a car turn, that is rotational motion. Okay. Translational motion is whole body movement from one place to another. You can consider the movement of a stone that is thrown up and is coming down as translational motion. Okay? You can also consider the movement of a car itself as translational motion, as it involves the whole body of the object moving in the same direction. Okay? Oscillatory motion is to and fro movement, like the movement of a pendulum. Okay? Pendulum, simply put, is when a string is tied to a stone and it is allowed to hang. When a string is tied to a stone and is allowed to hang, okay, when this stone is pushed and released, it will be moving to and fro. This is called oscillatory motion. Okay, it will be moving here, come back, move here, come back. That is to and fro movement. That is oscillatory motion. Random motion is the kind of motion in which there is no clearly defined path. The path change from time to time, like the movement of gas molecules. Okay, when you see a smoke, you know how smoke moves. It moves in a random version. That is, you can't predict where smoke will go. That is random motion. Okay. Why do body move? Basically, body move because body usually move when an external force acts on them. And that is explained by the first Newton law of motion, which says if an object will remain at rest or moves in uniform motion unless acted upon by a force. If something is kept on the table, if something is kept on the table like this, that thing will continue to be in that position until when someone push it. That is first Newton law of motion. If you hold up a stone at an height from the floor like this, if you hold up a stone at an height like this and you release it, the reason why it comes down is because the force of gravity, the gravitational force is acting on it. That's why it will drop. In the space where there is no gravitational force, if you leave a body, that body will continue to be where it is until when an external force acts on it. Okay? Basically, what I'm trying to say is that according to the first Newton law of motion, body moves when body moves only when an external force acts on it. Okay? It will continue to remain at rest or be moving uniform motion. What is meant by uniform motion in this place is constant velocity, okay, which we'll talk about later as we move on in the topic. What are the different types of force that can cause body to move? Generally, force can be classified as push, that is away, or pull, that is towards. Broadly, forces can be categorized into these two broad categories. Okay, and force can also be categorized into contact forces or force field, depending on whether there is contact between the source of the force and the body or not. Okay. Example of contact forces is applied forces. When you push or pull, that is contact force. When a stone is resting like this, okay, and someone push the stone, okay, that is applied force. It's a type of contact force. Frictional force is the kind of force that resists motion. When you place a block on a table, when a block is placed on the table, or let's say a book is placed on a table, and the book is pushed on top of the table, usually there is a force between the table and the book that tends to oppose this force that is trying to move the book in this direction. Okay, that is frictional force. Frictional force is a kind of force that resists motion between two surfaces. That is frictional force. It's a type of contact force because it requires contact between the body and the surface. Tension force is the kind of force that is transmitted through ropes or strings. When two people pull ropes in opposite direction, the kind of force that will be on in this rope is the tension force. Okay, it's a kind of force that is usually transmitted through string, and it's a type of contact force because it requires contact between the the source of the force and the body itself that is experiencing that is receiving the effect of the force. Normal force is a kind of force that acts perpendicular to a surface. Okay, it's a force that acts perpendicular to a surface, and it's a type of contact force. So anytime you hear normal force, it means a force that is perpendicular to the surface in which on which it is acting. That is normal force. Okay. Here resistance is also a type of contact force. Okay, because it requires when you are moving in a wind that is blowing either in opposite direction to your direction of movement or in the same direction. You see that it has ways of either resisting your movement or aiding your movement. So that's also a type of contact force. Okay. Now to the force fields, the type of force that doesn't require contacts between the source of the force and the body on which it is acting is called force fields. And examples are given below: gravitational force, which is the force of attraction between the earth and other body. The shape of the heart is gird. Simply put, you can call it spherical anyway. And there is always force of attraction between any object and the earth. The force of attraction between any object or body and the earth is called gravitational force. Okay, the heart tends to pull all objects towards itself. Okay, and that is called gravitational force. Electric force is a force of attraction or repulsion between charged particles. Okay, in the Harmattan period, you realize that when you rub a wool and you take that wool close to a long hair of an adult or a child, you see that the air usually move away from it. The air usually move away. This is a type of electrical force acting between the cloth that is rubbed and the air. Okay, and this not a contact force, it is force fields, because there will be no contact between the source of the force and the object on which it is acting. Magnetic force is another type of force fields, and as we know that like poles repel and unlike poles attract. When you bring magnets close to each other, if you bring north pole and north pole close to each other, there is usually a repulsive force between it, despite the fact that there is no contact between them. So, making magnetic force a kind of force field. Another concept we need to talk about is relative motion. And relative motion is, we talk of relative motion when when we are talking of two objects that is either stationary or moving together. For example, two moving cars on the road. Let's say there are two moving cars. Let's say there's another car. If these cars are moving either in the same direction or opposite direction, let's say they are moving in the same direction, and another individual is standing, not walking, maybe just sitting down, the velocity, the relative velocity between this car that is going in this direction and the car that is following it, and the velocity between this person that is staying, not moving, and this velocity of this car is usually different. So we talk of relative velocity between two objects. Okay, we talk of velocity of one object relative to others in relative motion. Okay, that other body may be stationary, like the individual that is standing by the roadside, or may also be in motion, like this car that is following this. Okay? And when you want to calculate the relative motion between two objects, you need to consider the direction of movement of the two bodies. If they are moving in the same direction like these two cars, the relative velocity between them will be the velocity of this v2. Let's say this one is moving at velocity v2 and this one at v1. The relative velocity between them will be subtraction. It will be subtraction, will be v2 minus v1. Okay? But when they are moving in opposite direction, this v2 plus minus v1 is when they are moving in the same direction. But when they are moving in opposite direction, let's say these are two cars. Let's say these are two cars. Pardon my poor drawing skills. Let's say these are two cars moving in opposite direction. This one moving this way, this one moving this way. The relative velocity between them will be, let's say this one is moving at v2 and this one is moving at v1. The relative velocity between them will be equals to v2 plus v1. Okay? So take note of that as you need it when you are doing calculation on this topic. Now, let's go through some questions for us to test our understanding and to also consolidate what we know already. Question 1. Which type of motion is exhibited by the hands of a clock? Translational motion? No, because translational motion is the movement of the whole body from one point to the other. Okay? So, rotational? Yes, because it's the body spinning, okay, moving in a circular motion. Okay? Oscillatory motion? No. Random motion? No. That's not correct. So the correct answer is A, rotational motion. A car moves with uniform velocity. Which of the following is true? No net force acts on the car. No net force acts on the car. This is true as from the first Newton law of motion, we know that the first Newton law of motion states that body will continue to be at rest or move with constant motion, which otherwise known as constant velocity until an external force acts on it. So the correct answer is A. Friction is greater than the applied force. No. Applied force is greater than friction force. No. The car is accelerating. No, the car is not accelerating. Because when a body is moving at constant or uniform velocity, v2, the final velocity, v minus initial velocity, u will be equals to 0. Okay, so and as we do later, as we discuss later, acceleration is change in velocity over time. Okay, so which will be equals to 0. So the car will not be accelerated. Which force keeps the planets in orbit around the sun? There is a kind of force in the solar system that make the Earth to continue to revolve in its orbit, and that force is the force of attraction between the two bodies. That is the sun and the planets themselves. Okay, so let's see option 1, magnetic force. That's not true because magnetic force applied to magnet. Frictional force is the force between two flat surfaces. Okay. Gravitational force, yes, that is correct. Electrostatic force, no, this is not correct because electrostatic force has to do with electric charge. Gravitational force has to do with the force between the planetary body, usually the Earth, and the Sun. Okay. Gravitational force has to do with the force of attraction between the Earth and other body. Which of the following is not a field force? I believe you should be able to answer this yourself. Okay, the answer is there. And I'll leave the remaining questions for you to answer. Contact force, pendulum clock is an example. I think you should be able to answer this. What is the relative velocity of two cars moving in opposite direction? Don't forget, when bodies are moving in opposite direction, the velocity, the relative velocity between them is plus. When they are moving in the same direction, it is minus. So check it out in the past slides. Which force is responsible for holding objects on Earth's surface? I believe you should be able to answer this. Comment your answer, write your answer in the comment section below, and let's open the discussion so that we can understand better. Which of this represents Newton's first law of motion? Okay. What is the force that opposes motion? Which force allows a magnet to attract ion? Okay. I believe you'll be able to answer most of this question. Don't forget to like this video, subscribe to my channel, and share for others to benefit. And after you subscribe, try to click the bell, the bell sign, so that you'll be notified when I upload new videos. Okay. Which type of force causes a stretched spring to return to its original position? Tension force? No. Tension force is usually in strings. Okay. Or ropes. Restoring force. Restoring force, yes. Restoring force tends to allow the uh, elastic body to return to its original form. That's restoring force, which is correct. Frictional force, I believe you know that. Gravitational force, I've explained earlier. Okay, thank you for listening. But before you go, don't forget to like, share, and subscribe to my channel and click the bell icon after you subscribe for you to be notified when I upload new videos. Until I see you in my next video, I wish you the best and take care. Bye bye.